Today we're going to look at index laws, multiplying and dividing powers. So just to recall that when we have an index or exponent, the number that is at the root of the base is called the base there, and the raised number is called the index, or it's called the exponent. And what this means is that we have a, and we've multiplied it out n times. So we have n copies of a, n number of a's. So we've got a times a times a times a, n times. And it's a more compact and easier way to explain when we need to multiply something a large number of times. So for example here, 2 to the power of 6, or 2 with an index of 6 or an exponent of 6, is equal to 2 times 2 times 2 times 2 times 2. You can see we have 6 2's there, 1, 2, 3, 4, 5, 6. Okay, so then we can have a look at different laws and ways of easily simplifying these exponents to make it easier for us to look at. So the index law is for multiplying powers with the same base. So if we're multiplying two numbers together and they both have the same base there, so they've both got the base of a for this time, this one here, we can add the exponents together. So a to the power of m times a to the power of n is equal to a to the power of m plus n up the top there. So looking at an example, x to the power of 3 times x to the power of 2, that is the same as, if we were to expand x to the power of 3 out, that would be x times x times x there, x times x times x. So that's the same as this here, multiplied by x to the power of 2. So that's x times x there. So you can see now we've multiplied together 3 plus 2, we've multiplied 5 x's together. So that's the same as x to the power of 3 plus 2, x to the power of 5. So that's where this law comes from. It's just in a simpler way of explaining that, well, we're just multiplying, because we're just multiplying two exponents with the same base together, we're multiplying 3 for this first one, and multiplying another 2. So we're multiplying 5 in total. So it's the same as x to the power of 5. Now index law 2 is for dividing powers. So it's a similar sort of thing, but instead of subtracting, instead of adding the powers together, we subtract them. So if we've got a to the power of m, notice the same base again, a to the power of m divided by a to the power of n, that's equal to, that's exactly the same as a to the power of n over a to the power of n. It's exactly the same way that we can express a fraction or a quotient, a division problem, using a fraction kind of looking device. And that's equal to a to the power of m minus n. Now the reason for this is, could hopefully be clear if we have a look at an example here. So 1 to the power of 7 divided by y to the power of 3, that's the same as y to the power of 7 over y to the power of 3. So that's y times y times y 7 times there, divided by y times y times y, so 3 times there. And you can see that if we actually divide the top and the bottom by y, divide the top and the bottom by y, that will remove one of the y's. Divide the top and the bottom by y again, it will remove another y from the top and the bottom. And dividing the top and the bottom by y again, so that we've actually divided the top and the bottom, we've divided the top and the bottom by y cubed, we've done the same thing to the top and the bottom, we're actually left with y times y times y times y. So we've got 4 y's left over. So y times y times y times y, we've got 4 y's there. So that's the same as y to the power of 7 minus 3, y to the power of 4. So that's another reason for why we can do this very easy little law here. The reason is that we are essentially dividing the top and the bottom by the same number of y's in this example here. And we're left with the 7 minus 3, 4 y's left over, so 1 y to the power of 4. Let's look at some examples now of simplifying some indices. Indices is the plural of index. So x to the power of 3 times x to the power of 4. Let's have a look at that one. That's the same as x to the power of 3 plus 4. That's x to the power of 7. Here now, a slightly more complex multiplication one. 2 x to the power of 4 y to the power of 3 times 5 x to the power of 2 y to the power of 8. So we need to have a look at what are the same bases here. We can't combine the x's and the y's together because they're different bases, they're different variables, they might stand for different things. We can combine the numbers together, so 2 times 5 We can do that very easily because because we can multiply in any order. And now we've got the x to the power of 4 times x to the power of 2. So that's x to the power of 4 plus 2. We've also got y to the power of 3 times y to the power of 8. So that's y to the power of 3 plus 8. So we're left with the 2 times 5 is 10. X to the power of 4 plus 2 is x to the power of 6. And x to the power of 3 plus 8 is, y to the power of 3 plus 8 is y to the power of 11. So that's our simplified expression there. 10 times x to the power of 6, y to the power of 11. And you can see that it's a much simpler kind of and much more compact expression than the initial problem that we started out with. So looking at division now, looking at some division ones, u to the power of 20 divided by u to the power of 5 is u to the power of 20 minus 5. So that's the same as u to the power of 15. Now looking at a more complex one here, we've got 10 to the power of 10 times a to the power of 10 times b to the power of 6, all divided by 4 times a to the power of 3 times b to the power of 2. So here the 10 divided by 4 we can separate out. We need to make sure that we're keeping the bases separate and not dividing a's and b's together. We can't do that because there might be different values, but we can have a look at simplifying the indices for each different base. So for a's, we can simplify the 10 divided by, a to the power of 10 divided by a to the power of 3 to a to the power of 10 minus 3. We can also look at simplifying the b to the power of 6 divided by b to the power of 2 as b to the power of 6 minus 2. Notice that they're multiplied together, multiplying them all together, and that's because we're multiplying them together on each level, we're multiplying them together on the top, so we're not dividing in between or anything like that. It's the whole thing at the top, the whole numerator, divided by the whole of the denominator. So we can simplify the 10 over 4 to 5 over 2, divided by the common factor of 2, divided by 2 on the top, divided by 2 on the bottom, and we get 10 divided by 2 is 5, 4 divided by 2 is 2, a to the power of 10 minus 3 is a to the power of 7, and b to the power of 6 minus 2 is b to the power of 4. So there are a couple of ways we can express this. We can express it as a fraction times a to the power of 7 times b to the power of 4, or we can express it as 5a to the power of 7b to the power of 4 divided by 2. They're exactly the same values, because and the reason that we can do that is because we can do the multiplying and dividing in any order, just so long as we make sure that we're separating them out appropriately.